Assalamu alaikum students, very good morning. I welcome you all to the lecture series by the Department of Mathematics, the New College, Chennai. The previous video, the part 1 video, we actually seen the eigen values of the given matrix A. Those were lambda is equal to 1, 5 and minus 1. So if you haven't checked that video, the link is given in the description. Please go and check that video first, and this video is the continuation of that video. So we have found out the eigenvalues in the previous video. So for those corresponding eigenvalues, we have found out the eigenvectors in this video. So let us now start to find the eigenvectors. To find eigenvectors, we need a matrix, that is A minus lambda I times x is equal to 0. So this is nothing but lambda times I is nothing but, we know the identity matrix is 1 0 0 0 1 0 0 0 1. We have taken a 3 cross 3 identity matrix because we are dealing with a square matrix of order 3. So if this is your identity matrix, lambda I is going to be lambda 0 0 0 lambda 0 0 0 lambda, and hence the matrix A minus lambda I will actually subtract this lambda from the given matrix from all the diagonal elements. So this is going to be 2 minus lambda 2 1 1 2 minus lambda 2 1 3 1 minus lambda. So A minus lambda I matrix is going to be 2 minus lambda 2 1 1 2 minus lambda 2 1 3 1 minus lambda. So this times x, A minus lambda I times x. So x is actually, we are going to take it as a column matrix x1 x2 x3, and we are going to equate these two matrices to 0 by the assumption. So this value is going to be the first step to find the eigenvectors. For all these lambda values, we have already obtained 3 lambda values. We are going to substitute them one by one and get the equations, and we are going to solve them to get the corresponding eigenvector. So when lambda is equal to 1, so we are going to substitute at the place of lambda the value 1. So that is 2 minus 1, 2, 1, 1, 2 minus 1, 2, 1, 3, 1 minus 1 times x1, x2, x3, and this has to be equated to the column matrix zeros of all zeros. So now we get the matrix to be 1, 2, 1, 1, 1, 2, 1, 3, 0. x1, x2, x3 is equal to 0, 0, 0. So we are actually multiplying this matrix that we have obtained with this column matrix x1, x2, x3 and equate it to 0. That will give you 3 equations, that is 1 into x1 plus 2 into x2 plus 1 into x3 is equal to 0. Likewise, 1 into x1 plus 1 into x2 plus 2 into x3 is equal to 0. Likewise, 1 into x1 plus 3 into x2 plus 0 into x3 is equal to 0. We get 3 equations from this matrix multiplication. So those are x1 plus 2 x2 plus x3 is equal to 0. Likewise, x1 plus x2 plus 2x3 is equal to 0. x1 plus 3x2 plus 0x3 is equal to 0. Let me take these 3 equations are 1, 2 and 3. One can actually verify that every single equation is unique, so they are not same. So we can choose any of the 2 equations by using the cross multiplication method, and we can find the values of x1, x2 and x3. So let me choose, since I have 0x3 in equation 3, I am going to choose in the combination of the equation 3. So let me choose equation 2 and equation 3. So on comparing equations 2 and 3 by using cross multiplication method, we get, so let us choose the coefficients of equation 2 and equation 3. So we start with the coefficients of equation 2, that is 1, 1, 2. Please take it one more time, that is 1, 1, 2. Moving on to the equation 3, that is 1, 3, 0, 1, 3, 0. So now just omit the first entry and the last entry. So cross multiplications of these terms will give you the x1 value, x2 value and x3 value. So x1 value is equal to, it will be obtained by cross multiplying these values. So 1 times 0 minus 3 times 2. So we get 0 minus 6. For x2 we get 1 times 2 minus 0 times 1, that is 0. For x3 it is 1 times 3 minus 1 times 1. So we get x1 divided by minus 6 is equal to x2 divided by 2, which is equal to x3 divided by 2. So I have common terms to be 2 here. So let me take it outside. So I get x1 divided by minus 3 is equal to x2 divided by 1 is equal to x3 divided by 1. So the first eigenvector for lambda is equal to 1 is minus 3, 1, 1. So this is going to be your first eigenvector for lambda is equal to 1. Correspondingly, using the same method, we are going to find the eigenvectors for lambda is equal to 5 and lambda is equal to minus 1 as well. So the next step is we are going to find the eigenvector when lambda is equal to 5. So we are just going to substitute at the place of lambda in the A minus lambda I matrix with 5. So 2 minus 5, 2, 1. So that is 2 minus 5, 2, 1. 1, 2 minus 5, 2. 1, 2 minus 5, 2. And 1, 3, 1 minus 5. So this is your A minus lambda I for this value lambda is equal to 5. So this is going to be x1, x2, x3 equated to the column matrix 0, 0, 0. So we get minus 3, 2, 1, 1 minus 3, 2, 1, 3 minus 4. So this is the matrix that we get by substituting lambda is equal to 5. Just like the previous process, from this matrix multiplication also we get 3 equations by multiplying minus 3 into x1 plus 2 into x2 plus 1 into x3 is equal to 0. Likewise 1 into x1 minus 3 into x2 plus 2 into x3 is equal to 0. 1 into x1 plus 3 into x2 minus 4 into x3 is equal to 0. Let me write out those 3 equations now. Minus 3x1 plus 2x2 plus x3 is equal to 0. Let me take this as equation 4. Next one is x1 minus 3x2 plus 2x3 is equal to 0. This is equation 5. And x1 plus 3x2 minus 4x3 is equal to 0. That is equation 6. So likewise, all these 3 equations are unique. So we can choose any of the 2 equations to get the values of x1 and x2. So on comparing equations, let me take 4 and 5. By cross multiplication method, we get minus 3, 2, 1, minus 3, 2, 1, 1 minus 3, 2, 1 minus 3 2. These are the coefficients of these two equations. I have written twice and I have cancelled the first and last entries. So cross multiplication of these values will give you the values of x1, x2, x3. So x1 is equal to, x2 is equal to, x3 is equal to. So 2 times 2 minus of minus 3 into 1, that is minus 3, minus of minus 3, so it is plus 3. 1 times 1 minus of minus 6 is plus 6, so plus 6. Moving on to minus 3 into minus 3 is plus 9 minus 2. So all the terms going to be x1 by 7 is equal to x2 by 7 is equal to x3 by 7. So the x2 eigenvector x2 is actually equal to, since we have all 7s, we can take 7 outside and make this as 1, 1, 1. So for the eigenvalue lambda is equal to 5, the corresponding eigenvector x2 is equal to 1, 1, 1. Likewise, we are going to find the eigenvector for lambda is equal to minus 1 as well. So when lambda is equal to minus 1, we got to substitute this value minus 1 in the A minus lambda I of x matrix. So 2 minus of minus 1. So it is going to be 3, 2, 1, 1, 3, 2, and this value is 1, 3, 1 minus of minus is plus, so 1, 3, 2. So let me write this as 3, 2, 1. The first row is 3, 2, 1. The second row is 1, 3, 2. And the last row is 1, 3, 2 again. Two minus of minus 1 is 2 plus 1. So 3, 2, 1. 1, 2 minus of minus 1 is plus 1. So 1, 3, 2. Here it is 1, 3, 1 minus of minus 1 is plus 1. So we get 1, 3, 2. So here, if we multiply this with x1, x2, x3 and equate it to 0, we get three equations again. They are 3x1 plus 2x2 plus x3 is equal to 0. This is equation number 7. x1 plus 3x2 plus 2x3 is equal to 0. That is equation 8. x1 plus 3x2 plus 2x3 is equal to 0. That is equation number 9. So one can actually find that the equations 8 and 9 are same here. So we are not going to compare these two. We are going to choose the other equation which is not same. So we are going to compare the equations 7 and 8 to find the values of x1, x2, x3. For this corresponding eigenvalue, lambda is equal to minus 1. So on comparing equations 7 and 8 by cross multiplication method, we get 3, 2, 1. Repeat them: 3, 2, 1. 1, 3, 2, 1, 3, 2. Omit the first and last entries. Cross multiplications of the inner terms is going to be your x1, x2, x3 values. So x1 value is equal to, x2 value is equal to, and x3 value is equal to. So we are going to cross multiply this. 2 times 2 is 4 minus 3 times 1. So 4 minus 3. For x2 it is 1 times 1 minus 2 times 3, that is 1 minus 6. The next one is 3 times 3, 9, minus 2 times 1 is 2. So we get x1 value as, so let me write it here. x1 is 4 minus 3, that is 1. x2 is 1 minus 6, that is minus 5. And x3 is 9 minus 2, that is 7. So the corresponding eigenvector, the values are 1, minus 5, 7. This is the eigenvector for the eigenvalue lambda is equal to minus 1. So collectively, eigenvalues are lambda is equal to 1, lambda is equal to 5, lambda is equal to -1, and the corresponding eigenvectors are x1 is equal to, so what is our x1? -3, 1, 1. -3, 1, 1. x2 is all ones, 1, 1, 1. And for x3 it is 1, -5, 7. 1, -5, 7. So we have found out the eigenvectors for the corresponding eigenvalues, which we have found in the part 1 video. So if you have not watched it, please do watch the part 1 video. The link will be in the description. So that will be the better thing to understand this proper video. So thank you so much. Practice well.